Okay, we're broadcasting now. Okay. So we have no public speakers signed up as of yet. So I'm keeping a close eye on it. Okay.
And do we need to call a roll, even though it's just a workshop?
We do.
Okay.
We do for stipend purposes.
Got it.
Although there are no minutes or anything like that with these. I should say, Taj, that little guy hanging behind you, just hanging on for dear life, always makes me laugh. Always makes me, whenever I have noticed it a few times.
Yeah, it's you know what it is? It's kind of hard. I don't want to, but the reason why there's a guy hanging, it's because it's the I have this old school like fan light.
No, I just thought it was a metaphor for.
Yeah, I know it works great. But he's just basically like a glow in the dark, switch for part of that light. So
Got it. It was just.
But people love it, so I keep it there.
Right. kind of keeps me humble.
I missed him when you were down in Palm
Springs. We're all
Springs.
in the same boat. Hello. Welcome, Dr.
Hello.
Nice to see you. Hi, Mary. Oh, we are broadcasting right now, so just I'm just moving people over from the attendee area, just so you should know.
Hi, Adrian.
Hi, welcome.
Hi,
you
everyone.
for joining us.
Thanks. Thank you.
Good afternoon. All right, we've got 1:30 p.m., but let's take another 2 minutes to let people in, Adrian.
Sure.
And folks, we are broadcasting, so just be aware that this is being recorded, and folks may see you if you're on camera or hear you. We're just going to take a moment to let in as many people as possible before we begin. Welcome, everybody. We're going to get started in just a minute. Hey, everybody. We're just about to get started. Just be aware we are recording, so anything you do or say, if your camera is on and you're unmuted, will be available to the public. So please caution yourselves. And Adrian, when you're ready, I'll go ahead and call the meeting to order.
Great. Okay, I'm ready.
Okay, good afternoon, colleagues. It is 1:31 p.m. Today is Friday, April 9th, and this is a special meeting of East Bay Community Energy. This is a special Board of Directors retreat, and we're meeting via teleconference pursuant to the state of emergency in the state of California. We're going to begin with a roll call, so I will turn it over to our clerk of the board to go ahead and conduct that roll call.
Great, thank you. Alameda County. Alameda County. Albany. Albany. Berkeley. Berkeley. Dublin. Dublin. Fremont. Fremont. Hayward.
Present.
Livermore.
Here.
Newark. Newark. Piedmont. Piedmont. Pleasanton. Pleasanton. San Leandro.
Present.
Tracy.
Present.
Union City.
Present.
Community Advisory Committee.
Present.
Emeryville
Present.
and Oakland.
And Oakland will be coming late.
Great. Thank you very much.
Thank you. And Adrian, I just want to confirm that this meeting will be posted on the website for new
Yes.
members of the CAC and new members of EBCE. I'm sure they want to catch up on
Yes.
today's topics.
This meeting is being recorded.
Very good. Thank you. So that'll take us to public comment, and I'll just confirm with the clerk of the board to see if anyone has submitted a speaker slip or electronic comment, which I would allow to be read into the record.
There is no one signed up for public comment.
Okay, and I will let the folks know who are attending via Zoom. Please go ahead and use the raise hand feature if you'd like to be recognized at this time. If you're calling in, I don't see anyone calling in, but if anyone chooses to call in, they can use *9 to raise their hands that way. And I am watching the attendees list, and I don't see any raised hands, and I don't see anyone accidentally in our panelists raising their hands at this time. So we will move on. So we've got our presentation on technology and analytics, and I will turn it over to staff, and I will ask the clerk to please mute anyone who's not muted during the presentation. Thank you.
Great. Hi, everyone. I'm Taj Aitlausin. I manage technology and analytics at EBCE. And today's special board retreat is an update on the EBCE technology and analytics team and activities. So I'll be sharing my screen. Great. It should be coming up shortly. Can you all see my screen?
Yes.
Great. So thank you again. This is going to be a presentation of kind of an update as well as an introduction for new board members about the work that EBC staff does in technology and analytics. I don't expect the presentation to go beyond an hour, and obviously welcome questions throughout the presentation, and I'll make sure to pause after various slides to just give an opportunity for people to ask questions or ask for more details. And members of the team are on as well today, so I may call on them as well for certain questions that are best answered by them.
Hey, Tosh, just so you know, it's not on kind of full slide presenter mode. It's sort of, we can see all the previous slides. Not a huge deal, but.
All right, let me just stop sharing and start sharing again because I must be sharing the wrong screen then.
You can just swap displays at the top and it should be okay.
Let's see, let me try that again. Thank you. I'm sharing this guy, share. How's it now?
Good.
Now it's full screen.
Thank you. Technical issue resolved. So the agenda today, we're going to go over the mission of the team and an overview of the team. We'll talk about the integrated data platform that EBC staff has put together to support its objectives. We'll then dive into some use cases of how we've been working to enable a data-driven organization at EBCE. I'll talk a little bit about an ecosystem of partners that we've been cultivating and working with. Then we'll switch gears a little bit and talk about some recent work that we've done in establishing a customer relationship management system. I'll touch a little bit on the current RFP that's out. We've talked about it at an executive committee meeting recently, so I'll just briefly touch on it. I'll share with you a tentative roadmap of where we would like to focus our efforts, mostly on things that will be relevant to the audience today. And then we'll close out by touching on a collaboration that we've been doing with other CCAs in this arena. So first, I wanted to kind of introduce the team and explain why there is a practice at EBCE that is related to technology and analytics. Listed here, quoted here, is one of the key recommendations of the EBCE Local Development Business Plan, which calls in multiple places as a recommendation for EBCE staff to develop an in-house integrated data platform and analytical capabilities to conduct ongoing load research and analysis. So this is something that was identified very early on during the development of the Local Development Business Plan, that in order to really to be innovative and best in class, EBCE should be developing an integrated data warehouse, particularly as it will really help to implement the right types of local development programs that EBCE laid out in the Local Development Business Plan. So the team that we formed at EBCE has as its mission to manage data, processes, and systems that ensure that we have this integrated data platform, and that our decisions and our operations as an agency are grounded in data and driven by analytical insights. So that's really the key mission of our team. I've put the headshots for the various team members who are on this panel today, and just wanted to do quick introductions so that you're aware of who's on the team. We have Diego, who is he is the director of analytics. He's a recent graduate of a PhD graduate of UC Berkeley, the Energy and Resources Group, and a resident of Oakland. Doug is one of our newest EBC customers, just moved into Oakland recently, and he's a graduate, a master's degree from Stanford. Kevin is born and raised in Oakland, just moved to Castro Valley from Oakland, also holds a degree from UC Berkeley. We have Sanjay, who is a resident of Pleasanton, and Sanjay is our data engineer, and joined us most recently and focuses on engineering data for us. Forgot to mention Doug is a modeler in chief and manages all of our models, and Kevin is our data scientist. And then I'm Taj, and I managed a team. And though I can't unfortunately claim because of residence to be an EBC customer, I do have quite long ties to the East Bay, and graduated as well from UC Berkeley. So a lot of UC Berkeley folks on our team that give Doug a very big hard time because of his Stanford roots. The first thing I wanted to talk about is the development of the EBC Integrated Data Platform as it was called for in the LDBP. So very early on, we decided that in order to be as effective as possible, we were going to build our data platform using Google Cloud technology. So we use the Google Cloud platform as a foundation for everything that we do in terms of managing and processing data. Our platform basically centralizes and processes all the data that's relevant to EBC operations, and I'll dive into what those data are. But the use of the Google Cloud platform means that our staff has access to really modern data science and big data technologies. And the development of this platform really was very unique, at least at the beginning, among CCAs, and so has really helped to contribute to significant innovation. Now, some people might be wondering why we would use a Google Cloud or cloud technology in general, and there's many advantages to that. I think one of the things that's important to understand is that when you're talking about data in the cloud, it's not just about storing the data, but it's actually about availing yourself of systems, technologies, processes that could be very expensive to build in-house, but that you can share the resources when they are in the cloud. So it means that you can do things very, very quickly. For example, we can aggregate, we have about 600,000 customers or so. We can aggregate the hourly usage of every single one of these 600,000 customers hour by hour to get a total load, and to do that over 4 years, and do that in the Google Cloud platform in less than a minute. The system will do all these aggregations in less than a minute. It's also very cost effective in the sense that that aggregation that I just described, which, using old school databases could take hours, takes, less than a minute and costs less than $1. And we have very good visibility into what the costs are when we use a platform like this. It's highly scalable in the sense that when we're not running a query like that, it doesn't cost us anything. And when we want to run a query like that, but do it 15 different times or across 16 different dimensions, for example, the systems will scale for us, and we'll adjust. And then during the weekends when nothing is or very little is being processed, there's no cost associated because we don't have this equipment that we have, running or have a cost of ownership for. It's also actually extremely secure, and that may be surprising to some people. But Google Cloud in particular is an extremely secure environment. Without going into too much detail, data in Google Cloud is stored both at rest, is encrypted at rest and in transit, meaning that even if somebody were to stumble on a file, the file itself would be encrypted, and without being able to authenticate themselves, that file is effectively unreadable. I would venture to say that the Google Cloud platform and its security is probably of a higher notch than the security of the source systems that we get most of our data from at PG&E because of this strong encryption both at rest and in transit. And the reason why there's so much security is because these types of technologies are used by medical organizations that keep highly sensitive records, as well as financial organizations that need the highest level of security possible. And then finally, it's modern in the sense that it's continually, new features are continually being added. We don't have to worry about having to do an upgrade or whatnot. And we have access to really cutting edge technology in terms of data science, in terms of big data, So the staff can really run their models, using really best-in-class technology and not be hampered with old servers or old systems. So this is some of the main reasons why it makes sense to use cloud technology, and EBCE really was the pioneer among CCAs in doing this. I'll touch on this a little bit at the end, but it turns out that a lot of our other CCAs have actually followed in our footsteps. And not only have they started to move to using cloud technology, but most of them are actually moving to the Google Cloud Platform as well. I'll stop there and see if there's any questions before moving on. Nope. Oops, and I pressed the wrong key. What did I do? Okay, there we go. So this diagram is very complex. I am not going to go into the details of everything. I really wanted to convey to the audience that we actually manage quite a complex environment. Again, cloud is not just files are stored in the cloud. There's a lot of systems that are running. So we use components of the Google Cloud Platform to store data, to warehouse data in a database, to query that data in a database. We use components of the Google Cloud Platform to run virtual computers that do a variety of different tasks for us. We store our intellectual property in a system called GitHub that does data versioning and keeps all of our scripts well organized and up to date and manages conflicts. We use a tool from Atlassian called Confluence, which is kind of a wiki or a knowledge repository that is related to all of our components. And then we interact with several implementation partners that also, most of them happen to use Google Cloud Platform, so it makes those interactions very easy. And then we use other tools like Google Data Studio for dashboarding. We build models and run reports. And then we've also started to integrate Salesforce into this environment. So the point of this slide really is just to kind of illustrate that there's a lot of complexity to the disintegrated data platform that we've been working with over the last 3 years. In terms of the data sources, I wanted to touch a little bit so that people kind of get a sense of what's the kind of data that we're dealing with. The big data is energy usage data. Thanks to the investment that the state of California has made in what's known as the smart metering infrastructure, we get either hourly or 15-minute electricity usage data for over 97% of our customers. So every single one of our 560 to now soon to be 650,000 customers, 97% of those customers either have a meter that generates hourly data, this is typical for the residential sector, or 15-minute usage data, which is typical for the commercial and industrial sector. So this is data that as a CCA, we receive from PG&E, and EBC has gone to great lengths to make sure that we know how to wrangle that data, use that data, organize that data, because it's extremely important to understand the shape of the load when you're trying to develop an energy efficiency or a demand response program. It's extremely important to understand how a customer consumes morning, day, and night, summer, winter, so that if you want to target a particular offering to them, that you have that understanding. And it's also very important to understand how groups of customers behave and how we potentially want to provide either incentives to modify the shape of that consumption, or maybe just assist the customer because they may have inefficient equipment. So that is the biggest piece of information that we receive, and that is the big data part of our platform. So we have that information all the way back to 2015, and we process that information every single day. So every single day we receive a file from PG&E, process that, put it into our warehouse, and it's available for us to use. In addition to that raw interval meter data, we also receive bills and what are known as billing determinants, which are the sums that go into creating a bill. So it's like the quantity to which you have to apply the price that is in a rate to figure out what the bill should be. We also get monthly reports from PG&E on electric usage. And we also have successfully worked with PG&E to actually get gas usage for our customers, because even though we don't supply gas service, understanding how specific customers share their overall energy footprint between electricity and gas can be extremely important, again, when designing programs and when trying to achieve some of those local development business plan objectives. So that's the usage information that we get. We also receive customer information. So PG&E is the master owner of what's known as kind of the customer details file, because PG&E is in charge of consolidated billing. So, you know, key information like name, address, phone numbers, email addresses, contact information, you know, whether the customer is a care customer, a FARA customer, that all comes from PG&E. We also receive customer, or are aware of customer enrollments when a customer enrolls into our service, or out of our service, or upgrades or downgrades their products and their product choices. So that's also information that we receive and process in our integrated data platform. The reason why there's a space there between those first 3 bullets and the remaining bullets is that everything below the first 3 bullets is actually data that we decided to go out and augment our database with. And that's also something that I think EBCE pioneered, or at least pushed the envelope on. So one of the things we do is we go to the tax assessor records, and we pull the tax assessor records, which are publicly available records. So the County of Alameda actually has a really, really good, easy way for us to pull that information. So when we pull the tax assessor records, we are pulling information on when was a house built, what's the square footage of the house, what's the value of the house. And then there's typically some additional information that's not always super clean, but like when was the house last upgraded? If it's a multi-story house, like what's the number of stories? There's also in the County of Alameda, there's these things called use codes that tell us, is this a single family house, a multi-family dwelling, a four apartment dwelling, et cetera, et cetera. So those tax assessor records, we ingest them and we marry them with all the information we get from PG&E. We do the same thing with census information, which is again publicly available information, and we marry that to our customers. We also use a data source called Cal EnviroScreen, which is a database specific to California that allows us to understand the different demographics as they relate to environmental issues, again, at a census level. So that's a database that allows us to identify potentially disadvantaged communities. There's a scoring system associated with that, which we again marry to our database. And then we've really done a concerted effort, especially in light of COVID and obviously some of the objectives of our organization, to get arrears from PG&E that we can make sense of. In light of COVID, this has been quite an important data set for us to work on, and we'll touch on it later. We've also really pushed and been, I think as well, been pretty pioneer, our regulatory team, in getting information from PG&E about who's being disconnected, how many times they're being disconnected, and why they're being disconnected. People get disconnected for many reasons, but this is the disconnections that we're trying to prevent. Many people get disconnected because they can't afford to pay. And so we want to find ways to help people avoid being disconnected. The only way for us to really do that is to start understanding the data by pulling in disconnections information. We'll touch on that as well later. We have information on PSPS. Those are the public safety power shutoff events that we've unfortunately all experienced over the last 3 or 4 years, or I think so, yeah. And so we know which customer has been impacted. And so if we want to target a particular program, for example, our Resilient Home program, to people who have been shut off 7 times, unfortunately, we have people like that in our database, we can identify them. And we can not just identify that they've been shut off, we can identify how much usage they have, we can identify how much gas usage they have, et cetera, et cetera. So that's all married as well into the database. And then one thing that we're doing as well to support the programs team is pulling in DMV records to understand customers that may be, interested in having electric vehicle programs marketed to them, but as well to understand who actually has an electric vehicle, because the DMV records will tell us that. PG&E doesn't tell us that. It just tells us the rate that the customer is on, but that doesn't necessarily mean they have an electric vehicle. So that's all the customer information. I'm sure I'm missing some things, but we keep adding to that customer information. And the goal here is to really have as much insights about our customers as possible. One thing I'll just point out here to understand is that although we do get customer details from PG&E, we do not get highly sensitive information such as social security numbers. Those are not information we get. We do not get bank accounts. We do not get driver's license. We do not get credit scores. So those are pieces of information that actually are not part of the general customer information we get from PG&E, which is also good because in a sense that information needs to be even more secured in an environment, in any data environment. And then finally, we have other data sources that are relevant to our operations. We pull information from the California Independent System Operator on price data at various nodes. So that is information that's published by CAISO, and we pull that directly. We also pull what are known as our day-ahead schedules. Those are the schedules for what we're going to be, what we're scheduling with the California Independent System Operator. We are actually, through our team, we actually generate load forecasts as well. And we pull those back, but short-term, medium-term, and long-term load forecasts. I'll touch on that a little bit later. We have a database of power procurement transactions that we pull in. And then we pull in a variety of other data sources. Google Sunroof is a project where it's a publicly available data set where basically every single house roof has been applied through a calculation that determines what the solar potential is based on the size of the roof, the angle of the roof, the location, north, south, east, west. And finally, we also pull in weather information as well. And this is just, a quick overview of the type of information we pull. But the point is that you want to marry all that information together into one central repository so that if you're interested in identifying customers in disadvantaged communities that have had multiple disconnections, that have been impacted by PSPS events, that use a lot of electricity during certain times of the day, you can actually identify those through this integrated data warehouse. I'll pause here again and see if there's any questions on data sources or.
So Todd, I will just highlight one question that appeared in our Q&A box, and the question is, how fresh is the raw interval data from PG&E? And this is for under energy usage information.
Great. So that's a great question. It's a contentious question, I think, in some areas. So how fresh is it? So we receive the data from PG&E typically about 4 days after the trade date. So currently, right now in the database, we have data as of April the 4th. Now, and that's just basically because it takes time for the data to get metered, packaged, sent to PG&E, for PG&E then to make it available through a system that we then interrogate and then we ingest. So we are averaging 4 to 5 day delays between when the meter was read and when we actually have that data. It's not great. For short-term load forecasts, it's actually as if you're driving in the dark, but it's the best we can do at the moment. I believe the system that EBCE has is probably the most efficient system across all PG&E CCAs in terms of the work that we've invested in making sure that we get this data as quickly as possible, and also honestly making sure that we achieve these 97% read rates. That is also something that other CCAs have struggled with. But here we've partnered with our data management service provider, SMUD, and we've really from the get-go said, this is extremely important. This should not be an afterthought. And so those are the metrics that we currently work with.
Great, thank you. And then there's a second question regarding customer information. Is there disclosure to customers about what their data is being used for and what data is being collected? And is there an option for customers to opt in or opt out? And this might be more of an Annie question, but I'll ask you, Taj, if you're aware of how we're notifying customers about how we're using their data.
Yes, absolutely. So there is a confidentiality policy that is available on our website, and that is linked through most of the communications that we share, or probably all of the communications we share with our customer, that informs them of the information that we use and collect. There's also very, very specific CPUC regulations that dictate how we as a CCA can and cannot use customer information, and when we need to obtain customer consent to use their information or share their information. So that's something we take very seriously. The CPUC regulation define different types of uses. So uses of customer information for the purposes of implementing energy management programs such as energy efficiency or demand response programs, those are called primary uses of the data, and CCAs are allowed to use the information to perform primary uses of the data without having to ask for customer consent to do that. But the part of the regulation that's more important is secondary uses. So if we wanted to use the data to do things that are not necessarily related to energy management, then we absolutely need to get the customer's consent to use the data before we use the data. And our policy at EBCE is that we never use customer data for anything that is a secondary use. All of the uses of the data is for primary use.
Great, thank you, Taj. Those were the only questions I see.
Great, thank you. So probably another busy slide, and don't worry too much about the details, but even though we have all this data that's available to us that we can process, it's not just like sitting somewhere in a in a cloud folder, if you will. We actually have built and we manage a process that runs every day. So every day we have systems that go and grab the information, grab the latest information as it's made available, either by pulling files that have been deposited for us or by using what are called APIs to go and pull the information. We then cleanse and we load that data into our system, into our core tables. We then do a whole series of transformations on that data to profile the data, to estimate missing data, to aggregate the data in ways that are important to us, to standardize addresses. This is one of the not very exciting thing that we have to do, but it's extremely important. Tax assessor records will say 123 Main Street, and PG&E will say 123 Main Road. Unless you do standardization, you're not going to think that those are the same addresses. So we have quite a significant amount of work going on there. Geocoding is also really important, where we transform addresses and locations into geo-coordinates. And then we do these processes every day, and then we feed it all into core tables and data sets that are then used to either feed into our CRM, which I'll talk again, or go out to different partners that need the data. And then they also feed a variety of different use cases that I promise I'm going to be getting into very quickly. But we have custom reports, custom dashboards, automated reports, automated dashboards. We can generate enrollment lists, target lists, and mailing lists for the programs and marketing teams. We refresh our Salesforce data model. Doug manages multiple revenue models and PCIA models. We do this thing called shadow SQMD reporting, which is we make sure that the data that is being posted back to the CAISO is that we calculate it separately from our data management service provider, and we make sure that it makes sense and it's accurate, because it's extremely important to be correct there. And then we generate short-term forecasts, medium-term forecasts, and long-term forecasts. So one of the key things that we've developed is to provide staff with a lot of self-service dashboards and reports that they can, go in and interrogate. And you're not seeing it in these screenshots, but these are interactive dashboards. You could say, I want to see what's going on, say, in Oakland with NEM customers, or I want to understand how many customers are enrolled in this product in this particular jurisdiction. So these are standard self-service dashboards that we've built. They're built using what's called Google Data Studio, which is again part of the platform, and they're giving people the ability to basically self-serve and answer their own questions without having to ask us to query the database. We also do a lot to try and enable a data-driven organization. So we manage a couple of auxiliary systems that facilitate a data-driven organization. I mentioned Confluence, which is it's an interactive wiki-like knowledge repository of all relevant information and documentation. It helps people understand what means what about what data that we have. And it's used across the organization, not just focused on data issues. And then we use Jira, which is a ticketing system when people want to put in ad hoc requests. Again, it's used primarily for people to ask us, hey, can you run a report where you tell me what's going on with this and this and that? We process hundreds of requests a year through Jira, but it's also a tool that's being used by other departments and is growing in use at the organization. We also are really happy to announce that we've graduated, I think more than 6 of our staff went through an internal SQL class that Diego facilitated so that they could themselves, SQL is basically it's the language you use to interrogate a database. And so we've done this so that they can actually start doing their own data querying on their own and, self-help. And it's been amazing to see the enthusiasm that people have. It's effectively, it's like taking Excel and putting it on steroids when you learn SQL and being able to do things that, otherwise they would have to write a ticket to ask us to do. And we're also supporting additional self-help tools such as QGIS to let staff do their own analysis and modeling. We also have automated reports that people can generate for some basic data requests that they have. For example, very often a customer will say, I want you to just give me a list of all the bills I've received and how much I spent on this and on that. So we have automated reports where you can do that for a particular customer.
Okay, and Taj, if you don't mind if I just take a moment to let folks know, colleagues, if you have questions, please use the raise hand feature. I will keep monitoring the panelist lists and attendees. If you have questions, also please use the raise hand feature, although I'm going to take your questions at the end in consideration of time. So, please forgive me. I was reading off of the Q&As, but we want to be able to make sure that we capture everyone's questions completely into the recording. So go ahead and use the raise hand feature. If you're calling in, please press *9 and I will take panelist questions as they come, and attendees, if you have questions, I will take them at the end of the presentation.
All right, so now we're entering what I hope will be the exciting part of the presentation, which is to go through a variety of use cases to kind of take this abstraction of an integrated data platform and start talking about how, some of the key things we've been doing with it. This is just a set of examples or use cases that I'm going to be walking through. First one is TOU transition. As most of you probably know, California is undergoing a transition to a time of use rates there's been a lot of marketing out there, keep California golden, 4 to 9. And so EBCE decided long ago that we were going to be part of that transition. It's actually starting to occur already in our service territory. But we really needed to know when we're doing this transition, first of all, there's going to be 2 types of customers. Customers are going to be defaulted, and we're just talking residential here. Customers are going to be automatically defaulted into this TOU rate. They'll receive a letter from PG&E, et cetera, and they can opt out if they don't want to, but they'll be defaulted into this rate. And then for a year, they have what's called bill protection, so that if somehow they don't, at the end of the year, they lost money by being on this rate, they can say, well, I want to go back to the original rate and I want to be made whole. So it was extremely important for EBCE to, even 2 years ago, to understand, first of all, what's the magnitude of customers that are going to be winners, and what are the magnitude of customers that are going to be, quote unquote losers, meaning those that actually should have stayed on the original rate. What is that going to mean for EBCE revenues if everybody transitions or nobody transitions? And what's the outlay that we potentially have if we need to do bill protection? Like, what's the additional amount of money that we have to, effectively put in reserve, if you will, because we know that these customers might actually ask for that money back as part of the bill protection. So The problem is pretty simple. Based on all the data that we have and based on the rate structures, who is winning and who is losing. So it sounds very simple, but the way we actually did it in our case is we took, again, all that hourly data that I was mentioning earlier, and for every single customer, we effectively ran 2 scenarios. We said, run a whole year's worth of history hour by hour using the E1 rate, which is the basic rate, and then do it again using the ETOU rate, which is the one that has on-peak summer, off-peak summer, on-peak winter, off-peak winter, and calculate for every single customer what the bill is under those 2 scenarios. And then for every single customer, determine whether they are better off on one rate or on the other, and then determine what, how much they would pay on one rate versus how much they would pay on other. And if there's a bill protection amount, what's the difference between those 2 rates? So it's not a hard calculation to put your head around, but if you think about it, doing it over a year's worth of data using hourly data for close to 400,000 customers, it's a pretty big calculation, not something you want to do in Excel, obviously. And it's something that the Google Cloud Platform enables us to do once it was programmed in seconds. It just runs in seconds, and then we can run it in different scenarios. So this graph is just showing you the blue bar is the total for all customers of what they would pay on E1, and then the other colorful bars is how much they would pay on the different buckets that they were that they potentially would have to pay on. So this enables us to do multiple things. First of all, it enables us to get an understanding of what the impact of this TOU transition is going to be to EBCE revenues if everybody transitions. It enables us to understand if everybody applies for bill protection, how much money do we need to have to pay them back if they want to get that bill protection back. And finally, it enables us to enhance the marketing, and this is the plan that we have, to enhance the marketing we're doing to customers that are potentially not going to be better off on TOU. PG&E is already sending notifications, but our plan is to use our analysis and PG&E's analysis to reinforce the message with those customers that potentially are at risk of having a significant impact from transitioning from the standard rate to the TOU rate. So that's the first example. I wanted to start with that one because I think it's pretty simple and to understand what it does, but again, I wanted to reinforce the fact that we don't do this as a summary, we do this customer by customer, and we have that information customer by customer because we have the tools to do it, and because we have the data to do it. Another example is the Resilient Home program. The Resilient Home program has been operational, I think, since July of 2020. It is a program that is on our website where customers can go on the website and say that they're interested in the program and see if they qualify. We knew we had all this additional information like PSPS events, et cetera, et cetera. So what we wanted to do is we wanted to receive those leads from the website when customers input forms. Those leads come straight into the EBCE analytics system, and then we enrich those leads. We say, here's who's care, here's who's FARA, here's who's medical baseline, here's who's in a high fire hazard zone, here's how many PSPS events this particular lead has had, here's what the Google sunroof potential says about the potential for solar, because this program is related to solar. Here's how old the home is, because that's actually very interesting when you're trying to figure out whether it makes sense to enroll a customer in doing some upgrade or not. We also create a disadvantaged community flag based on the Cal and virus screen data that we have, and a low income flag as well. And then we also we take again all that hourly data that we have, and we use that information to qualify the leads and to provide our implementation partner with all that information so that they can go, first of all, they don't have to, they can know who really is highly qualified, and they can contact the highly qualified or the prioritized respondents, and then they have access to all the information they need to determine what the opportunity is for the customer. So that's again an automated process. Form is filled out in the website, comes into the Google Cloud Platform, a process then enriches the leads and then sends them out to our implementation partner. I'll keep going unless there's questions.
I don't see any raised hands from the panelists, so please do keep going. I just want to give you a time check to Taj. It's 2:14 p.m.
Yeah, great, thank you. So another use case is preventing customer disconnections. This is something that's been extremely important to EBCE, and we've invested a lot of time and resources on this. But effectively, we're trying to see if we can proactively help customers that are at risk of frequent disconnections and prevent maybe the next disconnection. We want to preemptively reach out to those customers, and we want to focus our resources as much as possible. We don't want to just blanket send a note to everybody. We want to really send a note to those people that need help and that are probably at risk of a future disconnection. So what we've done with this information is we pull the historical disconnection information we've received from PG&E. We've looked at a variety of different data points. And here, this is where the use of the Google Cloud Platform enables you to use these machine learning and big data tools that enable you to build models and test models and rerun models. And effectively, what we did is we built a model. This was something that that Kevin on our team did. We built a model to really focus on at-risk census tracts and using information to see if we could improve the predictability of the model in identifying who's at risk of a disconnection. And without going to the statistics too much, but with this model, we went from predicting 16% to predicting 40% with 40% accuracy. Now, 40% accuracy doesn't sound that great, but it's a 2.5% improvement over just like doing it randomly or doing it in a blanket way. And because we can score customers according to this model, we know where to put our resources. We know that the ones that have a higher score are the ones that are more likely to be disconnected, so we want to reach to them first before reaching out to the ones that have a lower score, because according to the model, they're less likely to be disconnected. So the analysis allows EBCE to focus its resources on customers that are most likely to be affected by disconnections, and therefore to reach out to more people and to target our resources to those people that may need help with this particular issue. And I think the thing I wanted to just reinforce here is that building machine learning algorithms and data science algorithms is extremely easy when you're working with a Google Cloud Platform like environment, because all of the tools are at your disposal. All the systems are there for you to be able to do that. You don't have to like buy another computer that has a lot of processing capabilities just to do this particular activity. Another use case is using data to respond effectively. This is something that we've worked with as well. We receive information from PG&E about customer arrears, meaning how far behind they are in paying their bill. And unfortunately, due to COVID and because of difficult social circumstances, we've seen an increase in the customer with arrears in our service territory. It was very difficult for us to really process and understand the data that we were receiving from PG&E. And so we need to basically do a better analysis on the data. And so this is something that Diego and our team led, but we cleansed, monitored, analyzed, and processed all the arrears data so we would have a better understanding of what it looks like in aggregate, but also what it looks like customer by customer. We pull that information into both Google Cloud and in Salesforce so that we can have better organizational decision-making. And ultimately, the idea is to be able to use this data to prioritize those customers that need the most help with their arrears. And so cleansing and processing that data was also something that was extremely important to our programs team. And so that's another example of what we've done. Again, lots of massive information being processed and cleansed through the data management system. And then the last use case that I wanted to describe is one that is more relevant to our overall high-level financial health and operations, and it's calculating what's called revenue headroom. Headroom is a term that we use to basically determine how much money do we have after all of the expenses we have to pay, PG&E, et cetera, just to focus on energy. Obviously, there's the PCIA, which is a significant component of our customers' rate. That is money that is tacked onto our customers' rate, and that is recovered by PG&E. And so the analysis was extremely important, because the problem is, unfortunately, that, and what this graph illustrates, is that while in 2021, January 2021, the average rates paid by the customers actually dropped by 3.5%. So the customers are seeing lower rates. Because of PCIA changes, the actual amount of money that EBCE was receiving dropped by close to 15%. So that's significant, because just because there's a 3% decrease in rate in the customers doesn't mean that there's a 3% decrease in revenue to EBCE. There's actually a much more significant impact because of the interplay between PCIA and rates. And so being able to model this and being able to calculate this is extremely important for us to be able to do our correct budget planning, et cetera. And so this is a model that Doug on our team has worked on. And again, one of the key things I want to leave you with is that this model actually does it as well, customer by customer by customer. Most of the other models out there in existence just take a class in general and say, well, we're going to assume this or assume that. What we do is we model every single customer, calculate every single customer, and then aggregate this up to then get this answer from the bottom up aggregation. And then the power that we have with the platform we're using enables us to run multiple different scenarios. So, because we have to, what happens if the PCIA goes this way? What happens if this particular regulatory decision goes that way? So we can create multiple different scenarios and store the results of those scenarios and never have to worry about storage or about processing power. I think there's some questions, or...
They are some questions from the attendees, which I'm going to save towards the end of the presentation to make sure we have time for all of our colleagues to get their questions answered. So thanks everyone for your patience, but go ahead, Taj.
Yeah, we're doing well time-wise, so we should definitely have plenty of time for questions at the end. So, so that's the last of the use cases. So hopefully I've given you some hopefully exciting ways of understanding how we're using data and what we're using the data for to really inform our programs and our decisions, and really be data-driven in some of the use cases that we address on a day-in, day-out basis. I wanted to touch a little bit on the fact that we also are expanding the ecosystem of data partners that we work with. Again, the use of the Google Cloud Platform really was really key here. Myst, for example, is a partner that works on generating short-term load forecasts for EBCE. So those load forecasts is extremely important, because this is what we tell the California Independent System Operator we think our load is going to be. It is our responsibility as a load serving entity to be as accurate as possible in our load forecast. And in fact, last summer, there were, people probably remember the rotating outages that were going on, where there was several of those, one of the root cause of those rotating outages was the fact that there was a miss in terms of the load forecast. So we were really glad to be working with Myst, a partner. It's a seamless integration with our Google Cloud Platform, so we don't exchange files or anything. We just basically work in the same environment. They pull information from us. They then generate a forecast, which they return, and then we submit that to the CAISO through our scheduling coordinator. This graph just shows you an example. The load forecasting accuracy is measured by a statistics called mean average percentage error. Basically, for every single hour, you calculate the percentage off you were, and then you take the absolute value. So that if you're off by 3% one day and then off by -3% the other day, you don't say that you were perfect, because 3 and -3 average each other out. You say it's 3%, 3%. So you were off by 3%. And so Myst has been able to generate a MAPE on the order of 3% or less, which is very, very good given the limitations that we have, and has enabled us to really weather some of these issues that other CCAs have experienced quite well. And I think the reason why I'm putting this is that we're really trying to work with partners that are using the same types of technologies that we have. And one of the key things with this Myst partnership is, again, because we're both using the same types of systems, there's almost no delay between the data exchanges between the two parties. Nobody has to wait for a file to come and then load it and then do something with it. The data is just effectively almost instantaneously transferred between both parties. So that's an example of a data partner that we work with. And then another area of effort that we've invested a lot of time and resources in, and especially recently, and this has been led by both Diego and Sanjay on our team, it's to really push the envelope for a customer relationship management system. So about a year ago, we decided that it only made sense for EBCE to license its own customer relationship management system. Right now, I believe we're the only ones to do that, though things might be changing, but all other CCAs are letting the CRM, the official system of record for their customer, be handled by a third party, which is called the data management service provider. And we never were very comfortable with that, because the CRM is so important to, it contains everything. Who got billed when, by how much, when did they enroll, when did they disenroll? And so we embarked on this effort to build our own CRM. We looked at options and at different vendors, and we settled on Salesforce. And we've been working very hard over the last 6 months to basically take all this data that I've been describing so far, summarize it, package it, and make it available in the Salesforce CRM. And that enables our team to now have like yet another level of reporting and capabilities to be able to see, using a 360-degree view, what's going on with the customers. So, our team goes into CRM and they self-service. They say, okay, I want to send a mailer to customers that are eligible for a particular type of program. These are the features that I need to have, and here's what I want them to look like. And then I can actually save that list as a campaign and then do an email campaign with those customers. But even for our large CNI customers, this tool is extremely important to understand the relationships between a variety of different accounts and how they roll up to each other and have access to that information. So this CRM basically sits on top of the integrated data platform that we've put together. And it's really the foundation for us being able to bring future functions in-house, in particular the call center, which is part of our roadmap. So I was going to transition from here to talk about this call center and data management services RFP that we've put out, which we mentioned during our executive committee meeting last time. RFP was out. It's due actually today. So we're hoping to get responses today from different vendors. But this RFP really sought pricing and options for call center integration into our service territory. And also it calls for tighter integration with the EBC CRM and the EBC roadmap. So for us, this RFP is really the starting point to us putting together this roadmap of CRM activities that we plan to engage in. Starting in 2021 with the implementation of Salesforce CRM, we have a roadmap to integrate from a systems perspective more and more data, and to make our CRM more and more central to our operations, to the point where by 2023, we can transition to the EBC CRM as being the only system of record, and to transition the call center to actually operate on the EBC CRM. That deadline is not for the call center to be in EBC service territory. That can happen, and we want to make that happen way sooner than that. But actually integrating the call center technology so that effectively there's just one database and one CRM for people to work with. That's something that we hope to achieve by early 2023. And then shortly thereafter, we also plan to implement a customer data access portal, enabling our customers. Right now, they can only access to their information online using the PG&E portal, but to have access to their own portal to access their data directly. And again, the Salesforce CRM environment will enable us to do that as well. So that's it for the slides that I had. I had a couple of appendix slides that I can go over, but I will just pause here and see how we want to proceed.
Great, and I'm looking to my colleagues to see if there are any clarifying questions from board members or CAC members who are listed as panelists. I'm not seeing any raised hands, and I just want to remind people that you would use the raise hand feature to be recognized. And if you're calling in as an attendee, go ahead and use *9 to raise your hands. And if there don't appear to be any questions from the colleagues, I want to compliment the staff report, Taj. I think this was just the right amount of information, and everything was very clear. I do see our member from Livermore would like to speak, and I'll recognize at this time Member Kick.
Yeah, I don't have a lot of questions. I just want to say that I really appreciate how thorough this was, and it's really great that everything we're doing is so based on data. And I think that's really valuable for customers to know as well.
Great, thank you so much, Member Kick, for adding that. Member Lopez from San Leandro, you have the floor.
Well, thank you so much. I want to say thank you, Rich, for this information. It's impressive. I remember a number of years ago, and I'm starting to date myself, when this was just sorry about that, when this was just a concept, I'm having the CCA, and we sat in all of those steering committee meetings and then formed the JPA launch. And now here we are. And I'm very impressed with the level of sophistication of your work here, and this presentation is highly representational of people who are very smart within the organization. And I think I had not imagined all those years ago that we would be at such a good place, and in actually a relatively short period of time for an organization. And although it's many years for me, because politicians have dog years, in this case, you've really come quite a ways in, and I congratulate you and thank you for your work.
Great, thank you so much, Member Lopez. Seeing no more questions or comments from board members, I'm going to just check in with staff and see if you have the ability to stay on and answer questions from the public. And thank you again, colleagues, for attending. If anyone needs to drop off, it's totally understood. But if staff is available to answer questions from the public, we'll go ahead and take them. I would like folks to please use the raise your hand feature. I realize the chat's open and the Q&A is open. That was actually a mistake, but in order to record everyone's questions properly, I'd like you to use the raise hand feature and I will recognize you. First up, we have Igor Tregu. And Igor, you're going to have to let us know who you're representing today. I know you're in leadership with Sierra Club, but you've worked for many organizations in the past. So I just want to make sure who you're representing on this call. And Mr. Clerk of the Board, please go ahead and unmute Igor.
Igor is unmuted for 3 minutes.
Sorry, can you folks hear me?
Yes.
Yeah, I don't think I'm the Igor that you were referencing, but
I apologize. I thought you were Igor Tregu with Sierra Club, but please let us know who you are.
My name is Igor Siriebrany. I'm just a customer of East Bay Community Energy in Berkeley. Just curious about the technical work that you folks are doing. So my question was, it seems I was curious about why there was a decision made to build a lot of this stuff in-house. And the reason why I'm asking this question is because it seems like there's a lot of really good world-class work going on here. And I hear that East Bay Community Energy is kind of like at the leading edge of this, especially among other community energy providers. And I'm just curious, like, how do other community energy providers benefit from the kind of work you're doing? Are there like vendors who can make this kind of work available to other community energy providers? Because I think the goal is to, make electricity consumption better and easier for customers and lower impact across California and ultimately the world. So I'm just curious, how is this work getting out there and how do others benefit from it?
Great. Yeah, thank you very much for your question. In fact, I missed going over this slide, which is perfect for your question. So I'll go over it. It was the last slide. I thought I had gone over it, but I didn't. But Yes. So to answer your questions, we built the underlying infrastructure in-house for many different reasons. One, because that was something that was called out in the local development business plan. Two, because we wanted to be at least in control of the data that was core to our operations. Three, because a lot of vendors out there had very proprietary technology, very expensive technology that we felt ultimately was just going to lock the data away from us. And so we felt that the underlying structure needed to be something that was owned and operated by EBCE. And we've continued in that philosophy by making sure that we develop something that we can really manage and process internally without being beholden to any third party. That said, as I mentioned, we develop an ecosystem of vendors. So when the issue of developing a world-class time series short-term low forecast came up, we built it in-house. We tried. We didn't do great. We didn't do badly. We didn't do great. But we came across an organization called Myst that's what they do. And they didn't say, we are going to take all your data and you're going to pay us for all this data and we're going to give you something, a username and a password. All they do is they take our data, they generate a forecast and they return the forecast to us. And so it's a point solution and we're more than happy to partner with third parties that are really good at doing those types of things. Another example is Recurve that does a lot of help for us in terms of our pay for performance energy efficiency programs. We also have program implementers that also use the same technology. So that's in a sense the philosophy that we use. Now, in terms of other CCAs, we've worked very closely with many other CCAs, I think at first, to kind of open up this gate to say, you shouldn't be letting a third party control everything about your data. You really need to invest in data science resources. You need to invest in a technology like Google Cloud Platform. And the great thing is that many CCAs are now adopting this model. Sometimes they're working with third parties, but they're building something using an open cloud-based infrastructure. We provided thought leadership in this area. We in fact are responding to an RFP from Silicon Valley Clean Energy in conjunction. We're not responding, we're part of a team that's responding to an RFP so that we can assist Silicon Valley Clean Energy with best practices, some of the things that we've developed. As I mentioned, we've put everything that all of our intellectual property is in GitHub, and we manage a repository. And we are in conversations to work with other partners and other CCAs to potentially open source some of that work. I will say that one of the findings that we've had is that when we've offered to work with other CCAs, there's sometimes a little bit of reluctance that some other CCAs don't necessarily want to. They don't necessarily want to have another organization have access to their information or work or structure the way they do things. But that being said, there's a lot of work going on, and we want to continue to pursue this uniform front across CCAs because it enables us to do economies of scale. It gives us a uniform front when dealing with PG&E, which is extremely important when it comes to data, because there's a lot of issues that we have to deal with as unique CCAs, individual CCAs. And then we hope to share intellectual property through open source. So that's hopefully answer your question.
Thank you, Taj. And I just want to encourage attendee Jim Lutz to go ahead and raise your hand if you'd like to be recognized to answer your questions. And Adrian, when you have a moment, please unmute Jim Lutz. You'll have 3 minutes to comment or ask questions.
Okay, a couple, as long as you can hear me.
Yep.
Hopefully.
We can hear you.
A couple questions. One is, how is EBCE pushing back on the PUC and PG&E about the PCIA? It's probably not in Taj's bailiwick, but that's just a general question. A second question is, how much would the fresher raw interval data from PG&E help reduce the MAPE? And how much would that be worth on the, especially on the hot summer days like during last August heat wave? And those are my questions.
Yeah, thank you for your questions. On the PCIA, there's obviously a lot of activity going on. It is not my bailiwick. I think I will punt. There's going to be a board retreat coming up from the regulatory team soon as well, or a special workshop where they can address this more detailed. But there's a lot of activity going on both at EBCE and with the Cal CCA. It's a long-term issue that CCAs need to address, and obviously the predictability of costs is extremely important to healthy operation. So if you don't mind, I'll let that question go to our team, our regulatory team, when they do the update. The question on the MAPE, that's a really good question. I think I specifically spoke to the CAISO when they were doing a postmortem on the heat wave issue, and they asked us about our practices and the data, blah, 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 and I explained to the load forecaster that our data is up to 5 days old, and he's like, how do you even forecast? And so it is, I can't qualify or quantify what the improvement is, but significant improvement should be attainable when we get access to fresher data. It's a big challenge. We are on the record with the CPUC as that is looking into how to prevent potential future rotating outages. We are on the record with the CPUC as stating that we would love to see the systems at PG&E provide us with even fresher data. I think there's technical limitations to what PG&E can do without revamping everything. So we have to be realistic about it, but it would help. I think there is a lower limit though to the MAPE. At some point, going below 2% is really hard to do because there's so many things that play into this. And I'll just, as a quick excursion, the heat wave, and we have an article out there that I'm happy to share that we published in Power Grid International, but the heat wave in August, our error was much higher than, not much higher, but it's somewhat higher than 3%. I think it was more like on the order of 5%. But that error was due to the fact that the weather forecasts were wrong. And so weather forecasts are fundamental to energy forecast. And unfortunately, with climate change, it is becoming harder and harder to get accurate weather forecasts when you have situations like the one we had in California in August, which is a mixture of thunderstorms, smoke, and really hot days. And so that was the main reason why our MAPE was affected on those days.
Great, thank you so much, Taj. I don't see any further questions or raised hands, either from members of the board or attendees. So I want to thank staff so much for the presentation today. I appreciate each and every one of you, but I do want to go on the record and appreciate Sanjay's amps in the background. And I want to appreciate Diego's paintings behind him, because I think you get some special awards today for your collections. It's hard not to see everyone in person, but it is nice to see a little bit of everyone's personalities, the way that they choose to present their backgrounds. Kevin, I don't want to miss out on you picked a really nice background picture as well, but and Doug, of course. I want to appreciate everyone. Thank you so much for making the time to be here today. It was a really great presentation and a nice view into your very data-driven world team. So thank you so much. We'll see you all at the next workshop, and have a great rest of your day and a good weekend.
Thank you.
Thank you.
Bye.